Today's lesson is R.5 Day 1, Rational Expressions. I'm going to start off by giving you a definition of rational expressions, and that is two polynomials, p of x and q of x, such that p of x is over q of x, and q of x cannot be equal to 0. And so I know that's a lot of symbols and stuff that you're probably a little unfamiliar with, but main thing is that these are fractions. Look ahead to the first four examples. They're fractions of polynomials. And so p of x is a polynomial, q of x is a polynomial, and q of x cannot be equal to 0. Think about maybe why that can't be. And that should be, what you should be thinking is that q of x is in the denominator, therefore it can't be equal to 0, because no denominator can be equal to 0. So this is a definition of rational expression, and this is kind of what we're going to be dealing with. If you look at these examples here, it's just fractions with a bunch of x's and other variables in it. Okay, so domain is the set of all x values. So two definitions right off the bat. And what we're going to do is find the domain of this very first example. And I know you don't know what domain is, but think about the term fraction and what you know about the denominator. And looking at the denominator here, is there anything that x cannot be equal to given that this is a fraction? Okay, so what I want you to be thinking about here is how we find the domain is we set the bottom equal to 0 and you solve. And that number is what makes the denominator 0. So I'm going to write that makes the denom equal to 0. So that means x equals -2 is bad. So the domain is all real numbers except x equals -2. So the way that I write that is x cannot be equal to -2. That means take any number for x. Take 10. 10 can go in the denominator. That's fine because it doesn't make the denominator equal to 0. Take -100. -100 can go in the denominator for x. So it's any number except for -2. So this is how we write our domain. And it just comes from setting the denominator equal to 0. And then the domain is everything except any of those numbers. So I'll get to number 2 in just a second. But we also have to simplify. And so something that's really common here is someone might think that you have to cancel the x's and you just get -10 over 2, which reduces. Do not cancel the x's. You can only cancel something if it has been factored out. Okay, so something like that, this is simplified all the way. There's nothing else I can do to simplify. But if I move over to the second example, I know a lot of you might be thinking, oh, there's something that we can cancel. Yeah, the x minus 3's, those factors can be canceled, that's correct, but we first have to set the denominator equal to 0. So when I set this factor equal to 0, I get x equals 1, and when I set this factor equal to 0, I get x equals 3. That means that my domain is all the numbers except 1 and 3, because 1 and 3 are both numbers that if I plug in 1 or 3 to the denominator, it would make it equal to 0. So my domain is x cannot be equal to 1 and x cannot be equal to 3. This is my domain. That means that I can use any value of x in this problem except for 1 and 3. And so then when I simplify, I know that I can cancel the 3's right away. And so all I'm left with is x plus 4 over x minus 1. So I don't know if you've ever reduced fractions before when there are variables, but this is how you reduce them. It's just like reducing 2 over 4 to 1/2, but these have x's in them, and they're polynomials instead of just numbers. One other thing I wanted to mention about that is I want you to note still about the domain. The domain still includes -1 and 3, even though the factor of 3 canceled. You still have to exclude 3 from the domain. So 3 still cannot be in the domain. Even though it canceled, it's part of the original problem, and that's how you set the domain. It's in the original problem. So if you would plug in 3 to the original problem, that would be bad. So that is why our domain is not equal to 1 and not equal to 3, even though that factor of x minus 3 canceled. Okay, let's try this next one. What I'm going to do first is factor the denominator so that I can tell what values make it equal to 0. So that would be x minus 3, x minus 2. I'm going to equal both of those to 0. And so that means that my domain is going to be x cannot be equal to positive 3 because that would make a denominator equal to 0. And x also cannot be equal to 2. That's my domain, and now what we're going to do is see if anything factors and cancels. So I factor the denominator. I'm also going to factor the numerator, x minus 3 and x plus 3. I'm just going to cross those out so I don't get confused. And you can probably see that something simplifies and something cancels. We have an x minus 3 in the top and the bottom. So my simplified rational expression is x plus 3 over x minus 2. So those are the two parts to our problem here. Okay, so now we're going to get into a little bit of multiplying and dividing. And so just one thing to kind of think about when you are multiplying and dividing is that when you divide fractions, what that means is you're going to flip the second fraction and multiply. Flip the second fraction and multiply. So in this first problem, what I'm going to do is cancel some p's right away. So remember what you're thinking about this. If I'm just looking at these p's right here, what that means is that there's 3 p's on top and there's 2 p's on the bottom. So those cancel, there's 1 left over. So what I can do is cancel a lot of those p's. I can cross out all of these and the 3 exponent. And that just means there's 1 p left over. And the 15 and the 9 reduces. You can divide both of those by 3. So I'm just focusing on that first fraction for a second, just making it a little bit more simple. That means 5p over 3 times, don't forget you have to flip this second fraction, 10p squared over 6p. And yeah, I know that can reduce a little bit too. So I know this p can cancel the 2 on the top and just leave us with 1. And 10 over 6, that can both be divided by 2. That's going to give me 5 and 3. So now what I do is I multiply straight across. So what I'm doing is multiplying straight across here. 5 times 5 is 25, and there's 2 different p's on the top. So 25p squared. And then when I multiply across the bottom, I just have 3 times 3, which is 9. And then one good thing to do once you think you're finished with the problem is to check one more time and make sure nothing else cancels. And in this case, 25 over 9 does not reduce, so we're finished. Okay, but you'd be surprised how many people forget to flip when it's a division problem, so just be careful about that. Okay, this problem, what I notice is that there's a GCF here. There's also a GCF here. I'm going to factor those out. So I have x and x plus 1. Don't forget about that 1 placeholder. That's something we talked about regarding the quiz yesterday. That 1 there is really important. Over 25 times 5 over, there's a GCF in the denominator here of y, so I'm going to take that out. And now what we can do is cancel. We can cancel up and down, or you can cancel crossways. And I know you noticed that the 5 and the 25 can cancel. So I'm going to cross out the 5. That just changes to a 1. Cross out this, which changes to a 5. What I'm doing is dividing both of those numbers by 5. And you can see that the x plus 1 factors can cancel. Okay, so now multiplying straight across the top, I just have x times 1, which is just x. And multiplying across the bottom, I have 5 and y. That's just 5y. Quick check one more time to make sure nothing reduces, and it doesn't, so we're finished with that one. We're going to move on to this one. Okay, a lot of factoring we're going to have to do here, and please don't forget to flip the second fraction because this is a division problem. Okay, so I'm just going to factor a bunch of stuff really quick. That's why we just had a factoring quiz to make sure we're all good on factoring. M plus 4, M plus 1. Don't forget to flip and change to a multiplication. So right now I'm going to factor the denominator, but I'm going to put it in the top so that it is flipped. M plus 6, M plus 4, and the top is going to be M plus 2, M plus 3, but it's going to flip to the bottom. So I factored everything and flipped the second fraction all at once. And now what we're going to do is what I like to refer to as have a cancel party. The m plus 1s are gone. The m plus 4s are gone. and the m plus 2's are gone. And now we just have to focus on what is left over. And remember, you can cross cancel this way or this way. You can also cancel up and down. So those are the rules for canceling. What do we have left over? We have an m plus 6 and we have an m plus 3. So our simplified version of this rational expression is m plus 6 over m plus 3. Remember, you cannot cancel the 6 and the 3 because it's stuck together as a binomial with the m. So just be careful about that. You can only cancel if you have factored, and there are common factors. Okay, a couple more. Good news about these two is that these are already factored for us, so that makes it a little bit easier. So we're just going to start canceling everything that we can. Notice how x plus 2 and 2 plus x are the same thing even though they're in a different order. Addition, the order doesn't matter. So I'm going to cross those out right away. Notice that x minus 1 and x plus 1 are not the same. In fact, they are referred to as totally different. But here is something weird. Y minus 3 and 3 minus y. So here is a cool rule about when they're opposites and they're subtraction. You are allowed to cancel them as long as you take a negative sign and put it out front of your problem. So my simplified answer is negative parentheses x minus 1 over parentheses x plus 1. You need that negative sign, and here's why. If you're a little curious as to what just happened there, you can make this y minus 3, and you can factor out a negative 1 from the denominator, which is going to change the signs of everything in there. And what that means is you can kind of reorder that a little bit, is you have y minus 3 over negative 1, y minus 3. And now do you see that they actually do cancel? Except you have this random negative 1 hanging out. And that needs to be part of your answer. It's kind of like a GCF that you took out of that binomial. So you are allowed to cancel those. I like to remember just you can cancel them if they're opposites and it's subtraction. You just have to have this negative sign. I like to put it in front and it just stays in my answer. Okay? A couple more. What we have here is a little bit of factoring to do. I know I can factor this because it's a perfect square trinomial, and this also a perfect square trinomial. So what this is going to look like is x plus 2 to the third, x minus 1, x plus 1, all in the numerator. And the denominator cancels, x plus 2, x minus 2, and x plus 1. You can see stuff that cancels. X plus 1's are gone. And let's talk about what's going on here. There's 3 parentheses on top and there's 1 on the bottom. So think about if you would line up 3 of these parentheses. You could cancel one of them. I'm going to cross this out, cancel this, change it to a 2. Okay, because it canceled one of the parentheses on the top. So my final answer for this one, x plus 2 parentheses, x minus 1, x minus 2. If any of you are wondering, do I ever have to multiply any of this out? Do I have to FOIL for my final answer? The directions will most likely say leave your answer in factored form, which is with the parentheses exactly the way that we're doing it. But that's a good thought if you were thinking that. All right, you guys, one more. What we're going to do here is you notice that we have 4 terms, so we have some grouping stuff to do. So what I'm going to do is group these together and do my grouping tactic for what we learned on how to factor when it has 4 terms like this. The GCF of the first group is B. I have 4 minus A. GCF of the second group is D, and it's a positive D, and I again have 4 minus A. That's good. That tells me that I'm factoring it correctly, so I'm going to go ahead and factor it all the way. B plus D is one factor. 4 minus A is another factor. That's the top, and that's how that top part factors. I'm going to move over to the grouping down here now, just so I can get ready, because I know that this part and this part is going to factor pretty easily. So I'm going to get the hard part out of the way. This is going to have a GCF of C, and I have B minus D. I can take out a positive 2 and an A, and again I have B minus D. So that denominator factors into C plus 2A and B minus D. So I just did my basic grouping stuff, and then what I'm going to do is just factor this part now, stays in the denominator. So that's going to be 4 minus A and 4 plus A. Yes, the 4 does need to go first. The 16 is first, therefore the 4 needs to go first, and the reason for that is because of this minus sign right here. You can't reverse those or mix those up. Okay, I'm also going to factor this. B squared minus D squared, that's just another basic difference of squares. B minus D, B plus D. And now, with our multiplication in the middle, this is not division, so we don't have to flip anything. I'm going to cancel whatever I can. You can notice that 4 minus A's are gone. B minus D's are gone. And I think that's it. Some of you might be wondering, can I cancel this and this? Answer is no. Hopefully you know why, and that's because they're both in the top. When you multiply and you cancel, you can only cross cancel. So when it's both in the top or both in the bottom, they do not cancel out. So how are we going to write our final answer? Give myself a little bit more room here. What I have in the top is I have two separate B plus D's. You could write them both, or you could just write it as a factor squared. In the denominator, I have 4 plus A, and I also have C plus 2A. That is it, my friends. Make sure you bring your questions to class tomorrow. Thank you for watching. I'll see you later.